Right, hello everybody. I'm Dave Cridland, and I work for a company called Surevine, and they pay for me to come here, so I might as well put their logo on things.
Hello. Hello.
So Surevine do secure collaboration with people who really care about security, which is what draws me into this kind of area. But this is mostly just a hobby project that I've developed and we've taken on as a bit of a product. So XMPP looks a bit like this on a sort of a network diagram. You have clients which talk to servers, and servers talk to other servers. If we add in another client, it looks much the same, but you see that clients don't talk to clients, it's only that servers talk to servers. If you add in another domain, then you get, incidentally, please admire these lines, they took me ages. The blinky lines are CSS animation is really impressive, I thought. So these, you get domains talking to domains talking to domains, they all do full mesh, and the clients just hang off particular servers. But the problem with this is it's not a really sensible view of the world, because these two domains are both Montague. They're both probably on the same physical server. So in fact, they're probably in the same process, let alone the same organization. So the way that I tend to think about XMPP is like this. You have a set of if we're going to use posh language, autonomous security domains, which within them they operate their own security policy. They set the rules. The clients live within those. The servers live within those. Everything, and then they have borders, and then they send traffic past those borders into, in this case, Capulet sending to House Verona and House Montague. To the ages of Shakespearean research to figure out a third one there. So what's Metre? Well, I like to call it a borderline server, but marketing told me that I can't. So it's maybe an S2S proxy, a server-to-server proxy is one way of looking at it. A border gateway, although that's possibly a bit misleading. Yeah, an SBC in SIP terms, but XMPP doesn't have those. And a perimeter filter is another way of looking at it. There is another way of looking at it, but we don't mention that. So where does it fit in this diagram? Because I've got to put it in the diagram somewhere. And the answer is, well, it kind of doesn't, because this diagram doesn't change. What we're doing is Metre lives in these lines here, in these boxes. It acts as the border, it acts as the perimeter. So Capulet servers, however many it has, connect to its Metre as if it's Montague. They don't really care, they're just connecting out. So OpenFire, ProCD both have overrides to let you do this very nice and simply. Metre then pretends to be Capulet as it connects to Montague's servers. So it is fronting Capulet. I don't like that word pretends, though, because it implies that it's doing something wrong. There's lots of words that sound really wrong here. Spoofs, fakes, masquerades, all of these have to go. What it's doing is it authenticates as Capulet to Montague. It's legitimately acting that way. So, quick reminder of how authentication works in server-to-server in XMPP, because not everyone will remember this straight off, and it's a bit complicated. Originally we had dial-back. That was our first attempt at security in server-to-server, and it looks roughly that you've got two connections. One connection comes in, says, hello, hey Bob, it's Alice. The receiving server then connects back to the originating server and just checks that it's the right connection. And if it is, then we're all good. Dial-back is reliant on DNS. And here's an alternative fact quote from Trump explaining how good DNS is. DNS can be spoofed. There are problems there. We've never had a problem in the XMPP network, as far as I'm aware, but it's not good to rely on it. So
you wouldn't know. So
maybe we should do DNSSEC. And so DNSSEC secure DNS. I mean, it's the TLS for DNS. I don't know. I call it what you like. It means that you can rely on the DNS data at a cryptographic level. And this gives us something called securely derived reference identifiers, which are to do with...
It's not TLS, it's signing of records.
Hush now.
It's getting certificates, right?
No, it's...
So for TLS, in XMPP terms, we always have to check the certificate for the domain and not the host, unless we've got DNSSEC, at which point it's the host as well. Unless there's Dane, at which point it might be neither, or we might be doing something else with fingerprinting entirely. So there's a lot of variations there. TLS with XMPP is opportunistic. We use the Start TLS model, which was sort of pioneered by ACAP, as I'm sure you're all familiar with ACAP. I like to slip ACAP into every talk. Except that we've actually developed a quite recent spec, Z368, where it acts more like HTTPS, where it operates on a separate port. So there are, again, a lot of variations. Sorry, I did these last night when I was drunk. So Metre supports a selection of standards as beyond the basic XMPP, and I'm sure you all know what all of these are. So ZEP220 is?
Dialback.
Dialback, yeah. ZEP344?
No.
That's dialback with TLS. Then there's 361, that's SATCOM, XMPP over SATCOM. Metre supports that as well for low bandwidth situations. 368, we've mentioned, immediate mode TLS. 6125, TLS PKIX ORF, a rather obscure one because nobody seems to reference it. It's quite useful. 4033 to 35 is DNSSEC. 5280 is PKIX and CRLs. We have to do CRL checking. What's that?
Should have been Bosch.
And then we've got Dane and Dane SRV. So there's quite a lot there. The other features it can do are lots and lots and lots of per domain controls, so that you can tweak the cipher lists of particular domains. You can tweak the DH parameter length to particular domains if you want, and as well as whether you're enforcing TLS or not. It also handles DNS overrides. Oh, I should have really logged out, shouldn't I? Say hello to Chris. DNS overrides allow you to override what connection it's, what server it's connecting to, and everyone's coming on offline. I really should have thought of that before. It allows you to inject SRV records, and it allows you to, thank you Edwin, and it allows you to inject TLSA records so that you can do certificate pinning via injected Dane records if you want, which is again, useful. Quick trip around the internals. How am I doing for time? Okay. Quick trip around the internals. It's written in C++ 11 with bits of 14 as I gradually got familiar with them. So that might give you some idea of how long I've been working on this now. All of the code and all of its operations are assumed to be security sensitive, which has certain implications on the design. It's assumed that it is internet facing. It is assumed that it is right on the perimeter. It is assumed that every configuration option has a security impact. It's designed to be sysadmin-friendly. It doesn't have users. Users don't connect to it. It's designed to be support-friendly, so that we can build, Shorevine can build support contracts. And it's designed, once all of those are dealt with, it is designed to be very, very fast at switching stanzas, XMPP's sort of packet equivalent. To go through a bit more detail, I think this was actually Edwin. It was. There you go. That's why I picked C++ 11, because it's really nice. No other reason really. Security, there is no web interface. It's just a straightforward flat config file. You edit it with operating system security. There isn't even any SIGHUP support, because I decided that when I looked at it, to work out exactly which connections had to be restarted for a given config change, I simply thought was too high a risk, so that's gone. It does have pretty terrible testing, I will admit that. if any of you are Google Summer of Code students, I would love to see some approaches to a test framework for this. On the other hand, the code is very carefully statically analyzed, and it's exploratory tested fairly well. But as far as sysadmin-friendly goes, well, XML config file. Do we like XML? I don't know. I like it. It has smart cascading defaults, so changing a global will have an effect on other dependent settings to make them the sensible default given the global, this sort of thing. It also has a runtime config dump, which I'll come on to a bit at the moment. It really comes into its own when you're dealing with support. So by a runtime config dump, the config file that it reads in, it will then write out the entire configuration into a file. This is actually an example of part of the config file. Screen's not wide enough. But you'll see that not only does it write out all the settings, including any defaults, any derived settings, so it includes like the fact that we're checking PKIX status and this sort of thing. It also includes comments about the configuration. So in order to figure out exactly what your running configuration really is, you have a complete snapshot of it, including any reference certificates, keys, the whole lot, put in the data directory so that you can find it and examine it, and potentially examine it for changes. So fast switching means very few buffer copies, very fast parsing. I use a fork of Rapid XML, which I've enhanced a bit, and that one of the things that Rapid XML allows us to do is skip XML reserialization. Reserialization is at least as slow as parsing, so if we can skip it, we've skipped half the time. And what I mean by this is here's a stanza, and we've got what we tend to refer to as a stanza header. The message tags themselves, and what we can do is we can extract this string here and simply copy it from one buffer to another. Rapid XML allows us to do this. It makes it very, very fast to move stanzas from one interface to another, which keeps the latency very nice and low. So as I say, I wrote these while I was drunk. And so what can we do now? Because we are sitting in this diagram on these edges. Now that we're there and we've established the security between these at a basic communications level, what else can we do with this? So Metre has a concept of filters which allow you to read in the stanzas as they're going through, perhaps choose to discard them, perhaps choose to create new ones, so that we can respond to traffic that before it hits the real server, and potentially alter them. Only I haven't actually written the API for that, but you can always just discard and create new ones, so it's not a huge deal. The examples that I got, the XMPP world has a problem with Russian spam at the moment. So just as a proof of concept, I knocked out something that will take Unicode code blocks and go, yeah, it contains this one, and I don't speak any Russian, despite having Russian friends, and so I can drop those packets on the floor and my spam goes away. That's very, very nice, although quite brutal. But it's an interesting proof of concept. A slightly more interesting one is this. Disco is the capability discovery mechanism in XMPP. And what we can do is, as Disco requests come in for the discovery, we can hand back a previous discovery response so that, again, that never passes through. Now, this in combination with use of Metre in, for example, SATCOM, when you've got very slow links, can save quite a large amount of traffic.
Those XMPP servers already have the ability to cache client discos?
At least one does, because I put it in there before.
One does, because, yeah.
So, what's on the roadmap? On the roadmap, we've got the functionality, so what else can we do? We could actually suppress, maybe inject client capabilities, which seems like a useful trick to be able to do. So we can, instead of merely blocking, say, file transfer traffic, if you don't want to allow that across your perimeter, we might start saying, well, actually, this client can't even do file transfer, don't offer it, which improves the user experience instead of simply blocking traffic. Other things we can do, speaking of file transfer, we can intercept, maybe bridge between, so that we can inject file transfer proxies, things like this, strip out internal network addresses on peer-to-peer sessions, maybe even check files, maybe even dump them in and virus scan them on the way through. So we've got, again, a large number of options, things that you want to do on your perimeter. Finally, security labeling. Like I say, Surevine works in some high security environments, although we mostly use security labeling in cyber threat intelligence in the enterprise world. We've already got a complete security labeling implementation. It's called spiffing. I did a lightning talk on that last year. And so we can actually build in a policy enforcement point, check labels against clearances, exciting things like that. And we can do more than that. I'm really keen to, if anybody is a potential Google Summer of Code student, I'm really keen to see what people can do with this. You would be will be working within the XMPP Standard Foundation as an umbrella group for Google Summer of Code, and if you're able to pitch in an idea, I'm all ears. So with that. Ooh, I make it 3 minutes 20 seconds. Are there any questions?
Have you done interop tests between Metre and other servers or other border servers, edge servers?
Well, there is only one of them.
I know.
And you develop it.
I know.
So you can answer that question yourself, which would be not yet.
Right.
But I have discussed this with your CEO, in fact. And he said yes.
Okay.
So yeah, that's very much on the cards.
Because much as we like to have the entire pie, obviously, if we don't, we should at least interoperate.
Indeed, yeah.
Because there have been too many problems with interop.
Very much so. I mean, I run Metre in production against my protecting my own server, so I'm confident that it works with a wide range of servers. But yeah, formal interop testing, particularly with SATCOM. SATCOM and labeling, yeah, absolutely.
Got a question here.
Okay.
So, for myself, is it open source, and if so, where is it?
It is open source, and I really should have put the GitHub repository on here, shouldn't I? It is open source. Otherwise, that would be really embarrassing coming here and talking about something that wasn't, wouldn't it?
That's what I was
Yeah. So it's MIT licensed, and it is on GitHub. It's within my GitHub. You can look for Metre within my GitHub handle is DWD Delta Whiskey Delta. Flo.
Do you see that the issue that you don't see the remote IP is an issue or something you would like to solve? I mean, that's in the within the perimeter, you don't see the remote IP of the other entity.
No, you don't. That's because you will see Metre's IP address from the inside.
Is that a problem?
It's only a problem if you're trying to do security and perimeter security on the inside, but I'm assuming that you do the perimeter security within Metre.
Okay.
So I'm thinking not. Go on, I got 1 minute, 13 seconds. Anyone else? Marcus, I think you've made some time. Thank you.